Hi guys, I got a tutorial for you today. Wasn't planning on doing this one. I have two other ones that I had been planning on doing, but I'm subscribed to this guy here, Thinking Penguin, and he does good Blender tutorials. And he did this tutorial the other day, and I thought it was a pretty cool effect. And I had mentioned that I may try and do it in Lightwave, um, but I was going to try and do it a little bit differently. And he said he'd be interested to see how it was done in Lightwave, so I figured I would do it. So here's what we got here, and I'm going to say up front, this is not for the faint-hearted. I mean, it's nothing in here is too bad as far as complex, but there's like a lot of tedious logic, and it could have been done easier. You could get a very similar effect a lot easier than this, but there was a certain way I wanted to do it, and that made it a little more complex to set up. But I think it was worth it. But so here's what it is. So it's just this grid of triangles, and as they flip over, you can see they fade from one color to the other. So that's pretty much all there is to the effect. Now I did set it up so that everything is live. So like if you scale this triangle here, so say if we go to the triangle and scale it to 0.5, you'll see everything still works as expected. And you can scale the bounds, and the bounds is quantized as well. Um, so you can see. And the other thing I set it up so that you could do is that there's a lot of these are there's a lot of controls on this. I mean, not too many, but this grid here controls the fall off, and then the Y bounds here controls the amount on the amount of instances in each fan. So if I put this at 20, you'll see I get a ton more instances. It takes them much longer to go through. But what I set up here is that the rotation is hooked up to this. So instead of having it on 30 degrees, I can put it on 10 degrees. And now there'll just be a lot more instances, and they'll be much closer together. So you can see. So that's pretty much it. I did set up, there's some other controls set up on there too, which you'll see when I start setting it up for affecting the randomness and stuff like that. Alright, so let's just get started. So the first thing we're going to do is just load this object. And all it is just the bounds and an extruded triangle. We'll just put them on wireframe. And this is pretty much all we need for this whole thing as far as the objects. And we don't need to see the bounds, so I'm just going to turn that off so it doesn't render. Now I'm going to add nodal motion to the bounds, because what we want to do is we want to quantize the position and the scale of the bounds so that it adjusts if we scale the triangle. So I'm just going to get two item infos, one for the bounds and one for the triangle. So set the self and try. And what we need here is we need to get the width on the X and the width on the Y of the triangle currently. So the width on the X is 30 times, or cosine of 30 times 2. So that's what I'm doing there, getting the cosine of 30 degrees. And I'm multiplying that by 2. And that'll give us the X width. And then on the Z, it's just 1.5 meters. So now if we go and multiply, now what we want to do is we want to multiply both of them by the scale of the triangle. And that will give us an adjusted width and height for our quantization, basically. So Now I'm getting a split vector, so I'm just going to split the position and the scale of the bounds out, and I'm also going to get the scale of our triangle. And now I'm just going to multiply the x times the x width and the y times, or the z times the z width. So that'll give us a scaled distance. So now I'm just going to get a make vector. We're going to need a few of these. And I think I get AS tools here, vector clamp, because we want to clamp the scale on the x and the z so that it doesn't go below the one segment basically. And for now I'm just going to put the max at 200. Doesn't really matter, we'll adjust that later. That's just the max scale. So that's pretty much all we need. Now if we get a TrueArt Tools quantized scaler, we're going to need a few of these because we got to do it on a per channel basis because the x and the z get quantized differently. That's why we can't use a quantized vector. So we're just going to get 2 for the position and 3 for the scale because we don't need to move this on the y at all. So I'm just going to leave the y at 0. So we're just going to take the x scale of the bounds, or the x position of the bounds, and what we're going to do is we're going to do 1 divided by the y width, the scaled x width, and 1 divided by the scaled z width. And that's what we're using to quantize this with. And we'll go into the x and the z. And that's for the position. And then the scale is pretty much the same thing. So we're going to quantize the x scale and the z scale by, and the y, we're going to quantize the y as well, but we're just going to leave that one at a meter. But for the x and the z, we'll do them by the x width and the z width divided by 1. And then for the y, I'm going to leave it at 1. Because the y is not important. Because we're not moving it on the y. That's just to determine how many there are in each array. Now for the min, we just want to take the multiplied scale on the x and the z. So that's just making sure that doesn't get the minimum scale doesn't go below 1 segment. That's all that's doing. And I never put the angle on 30, so it's a little longer than it should be. So I'll fix that. And that's pretty much it. That's all there is to it. Now I'm also just making the y min at 1 too, but it really doesn't matter. Now the reason you want to do this is because it's not, you could do this in the instancer node editor as well, but the reason it's nice to have another object is because if you wanted to do like an infinite animation, you want to be able to move your instances around and have it be quantized. And that's why I like to do it this way. So all I'm doing now is I'm cutting all them out of there, except for the controls. I'm leaving the controls out, and I'm pasting it in a compound. Just trying to keep this somewhat neat because there's a lot of nodes in here. So I'm just rehooking up the outputs for the position and the scale. And then we got to create the inputs. So we need the position of the bounds, the scale of the bounds, and the scale of the triangle. So let me just rename these real quick. I think I just renamed the bottom one. Name it tri-scale. So I never hooked them up, so it's not going to work right now, but once I hook them up, it'll work. So if just look up the position, the scale, and the tri-scale. So now you'll see we're quantized on the X and the Z, and the Y is also quantized as well. So what I want to do is I just want to go back in here real quick, and I want to make the Y the minimum at 4. Just because I don't want it there to be any more than 4 or any less than 4. Now what we got to do here is we got to make an array of these triangles with instances. So that's what the next part of this pretty much is. So I'm just going to create a null called instances, and we're going to put our instances on this null. So I'm just going to add an instance or a DP instance, add the triangle, one motion blur step, wireframe, grouped on the pivot. For now we'll do 5,000 max instances. Open the node editor. So now what we're going to do is we're just going to make it pretty much a 3D array. So we're going to get the instance index, we're going to get an add, and we're going to add -1. And we're going to get the controls. So we need the same controls basically. We need the bounds, and we need the try, and we also need the. Now I could have used the global variable and just only used it in one spot, but because it was only two, I'm just going to redo them here. So we need the cosine of 30 and 1.5. I probably should have used the global variable. That would have saved me from having to do this. But I still would have had to have the global variable node, so it's really not that big of a deal. So it's just the same thing we had in the other one. Cosine of 30 times 2 and 1.5 times 2. Or 1.5, and then we 1.5, and then we multiply both of them by the tri-scale. So I'm just going to make vector into the position, and we're going to get the scale, split vector from the bounds, and the scale of our triangle. We'll multiply the X and the Z just like we did in the quantized part. So that gives us a scale distance now. And then what we're going to do is we're going to, now this is a little bit different, we're going to divide the scaled X and the scaled Z by the Y scale, or the X and the Z scale of the bounds, and we're going to round that, and that's going to give us how many are in our rows basically for the X and the Z. That's going to tell us how many instances are in each row for the X and the Z. So now we're just going to mod the index by Y, and you can see if I put that in the Y, it just counts to 4 over and over and over again. And then we're going to get a divide, and we're going to divide the index by Y. So that'll basically give us groups of 4. We're going to floor that. So this is just making a 3D array basically that's adjustable based on the size of the triangle. That's all we're doing here, which I'll demonstrate in a minute. So now what we need here is we need another mod. So we're going to mod that divided amount by the X. And you can see that we'll push them along the X. But notice we're only going 1 meter. We have to multiply that by the scale distance there. And that'll put them at the right distance in between. And then we do, for the Z, what we do is we get a divide and a floor. And we divide the X, or we divide the that our array by the x, and then we multiply that by the z offset. And if you see, if we go into the z now, it'll offset them on the z. And the way we can clip these extra ones is we could just multiply the x times the y times the z. So if we get the x times the z, and then we multiply that by the y, that'll give us the total amount of instances that we need in our array. So now, and then we can, so if we get a logic, we'll take the index and we'll take our total amount, and I'll say if A is less than B, and you can see now it just clips the extra instances. So now what we're going to do here is we need to shift every other row over on the X. So that's all I'm doing. I'm taking that Z offset there and I'm just modding it by 2. So it's going to count the 0 and 1 over and over again. And we'll say if it equals, if that mod equals 1, I think it's set to now, we're just going to make it be what it was. And you can see now they're all, the half of them stayed the same. But now what we do for this other one is just, we got to get a multiply. And what we want to multiply by here is this x width. We always want to get half of that no matter what. So that's what we're going to add here. Half of the x width. And then we'll go into the false, and you'll see that will shift them over, and that will keep it so that no matter how we scale that triangle, that it'll always be right. Now for the position, all we do is just add. We'll take our bounds position and we'll add that to our array position, and that'll allow us to move that around. So now I think I'm just testing this to make sure it's all working as it's supposed to. So if we scale the bounds, we should get more instances. And then also if we scale the triangles, you should see we'll also get more instances. So everything's working as it should. So now what we got to do here is we're going to create a compound that has the, just so we can keep all this separate from the rest, we'll only show the outputs that we need for the rest of the animation on this. And we'll keep the controls and the index, but all the logic I'm going to put in a compound. Just because I feel like when you start getting this many nodes in this many places, it's just a little bit easier putting it in a compound. I did have some stability issues with the compound node when making the inputs, like creating inputs. Not sure what that was all about, but I was able to work around it. So all I'm going to do here is this. I'm just going to cut all these out. Tools, compound, paste them in here. It's going to create the inputs, so we're going to need the index here. We'll call this inst index at 0. I'm going to call this bounds position. Call this bounds scale. Call this tri-scale. So that's all the inputs we need. Now we need more outputs because we need some of these for our animation. Now I'm just rehooking up all those inputs. That's all I'm doing here to where they were before. So now for the outputs, we need 2D array position. So that's giving us the 2D position. And we also need, that's the clip. That's what's going to turn them on and off, clip state, for the ones we don't need. And that's the Y index, so that's the modded by, that's modded by the Y, the index modded by Y. And that's the instance index at 0. And that's the Z offset. That's the Z scale of the triangle multiplied by the width of the Z width of the triangle. And then we need the Y bounds. So that's just the Y scale of the bounds. And we need that floored index there. So that's going to give us each individual cell. That'll be the cell index. So that's all the outputs we need for this animation now. Now I'm going to, we'll do the animation and then we'll put that in another compound. So I just hooked up the position and the clip state, so we're right back where we were. So what we're going to do here is I just want to do a little bit with the surfacing, just so we can see, have a little bit of a visual idea of what we're doing here. So the first thing I'm going to do is get an instance info. And what we're going to do is we're just going to clip out the object that wasn't the instance, the original object. So I'm just going to invert is instance, and you'll see now it cuts out that original object, so we're not rendering that. The other thing we're going to do is I'm going to get an edge node. I'm just doing this because it's a little bit, it makes it a little bit easier to visualize what's going on here. And I'm going to get a DP text gen, and I'm going to go into the background of the edge. And for the background color, I'm just going to pick this yellow color. And I'm going to load the font. And for the text, I'm just going to put 0. And we'll do a Y, planar on the Y. So I'm just putting the Y scale at 7 right now, just because that's it's a good amount to start with. And because what I'm going to do here is I'm going to mod this by 7. Eventually, I'm going to use a compound that's going to be taken from our scale of our control. But for now, just so we can visualize this, I'm just going to shift the index of our of the letter. So it'll basically start from 0 and then shift it based on the instance index modded. So it'll count through 0 through 6. Now they're all showing up on top of one another, so you're not really getting an accurate representation because every single one of these, there's 7 instances all stacked on top of each other. So that's why you're not seeing all the numbers right. But once we start moving these, you'll be able to see them numbered properly. So that'll all get changed, but I just wanted something so we could visualize this, what's happening here. Okay, so we'll go back in the notes. So the next thing we have to deal with is the animation for this. So I'm just going to get pi because rotation is important for this. And I'm going to scale pi by -1, so that's going to give me negative 180 degrees. We're going to get a logic here. And what I'm going to say is that if the Y index is less than 2, so that'll give me index 0 and 1 for each cell. So what I can do is I could say we'll multiply that index by pi. So we're going to be multiplying pi by 0 and 1, so it's going to give it, or negative pi, so it's going to give us 0 and negative pi. So we can create a rotation out of that. So what that's going to cause is for index 0 and 1 to rotate 100, or well, 0 will stay still and 1 will rotate 180 degrees. And that's what we have there. But you'll notice it's not accurate because of the way that our pivot is for our instance. So what we need to do to take into account for moving that pivot point is we need to get a matrix to HBB and a vector transform. So what we're going to need to do is we're going to need to affect the position as well. So I'm just putting pi divided by 2 just so you can see that all the 5 instances, 2 through 6, are all pointing down now, just so we have a visual representation of what's going on. So what we're going to do is we're going to get a divide, and we're going to take the z offset and we're going to divide that by 3 because that will always give us the right offset no matter how we scale that triangle. So we're going to take that vector and what we're going to do is we're going to transform that with our rotation here. So we just created a matrix and then we go into the transform vector. And then if we add that to our original position here, now it's messed up because it's supposed to be, I need to turn that transform on inverse transform. And you can see now we're all rotating around that center point. And that'll adjust based on if we scale that triangle or not. So that our rotations are always stay in the right spot. So all we're doing is we're affecting the position, being that our offset that we weren't, being that our pivot point was offset toward the center more, we had to account for that. Now I could have just fixed that in Modeler, but I thought it would be good to show that, how to do something like that. That's why I left that in there, because I could have just moved it in Modeler and not had to deal with that. So what I'm doing here is I'm creating the controls that we're going to use to animate this. So I'm just going to call this array control. And I'm going to add a custom object to it, just so we have something visually to see. Do a grid, 10 meters on the Z. So that gives us a grid there, and that's just something visually that we can use to animate this. So I clone that, and I'm making another one, and I'm making that at 4 meters just so it's a little bit smaller. And I'm going to make that the child of control 1. So control 2 is the child of control 1. So now you can see if I move control 2 out, and then I move control 1, control 2 will stay relative to control 1. So what I'm going to do is I'm just going to put a quick animation on this. Now the way I'm going to do this is with a planar fall off. So that's what this control is going to represent, a planar fall off, and then the distance for the fall off, and then a couple other controllers. But you can use any type of fall off to do this effect, but I just like doing it this way because I think it gives you a good amount of ways to flip these out. So I just created a little bit of an animation on that main null there. Okay. So now the next thing we have to do here is we have to get our controls. So I'm going to bring both of our controls in here. Now we need to affect the rotation based on that planar fall off. So we first have to create the planar fall off. So what we can do to do that is we could take the 2D array position, subtract that from our controller 1 position, and then if we get the math vector dot product and we dot that with our forward of our position, our control 1 position, that'll give us a planar fall off. So that dot there will give us a distance from the plane. So what we can do is we can get a remap. So I'm going to go into a scalar of this remap. And for the out maximum, what would I want that to be? So I'm getting a split vector there. So I'm going to take this. That's the position, the local position of our second control on the Z. So that's going to be the minimum that's the maximum distance in, and then we're using negative pi as our maximum distance out. So basically the Z position of our second controller is going to control how far the fall off is for our planar fall off. So now you can see now it's just going to all spin because they're not clamped. Now I could have clamped in that remap and that would have fixed it, but it won't because there's more stuff that we have to do. So what we're going to do is we're going to move all this over, and to that output there we're going to add the offset. And the offset is, we need to get the rotation here of our second control because we're going to use that for our rotation there, our step rotation. So what we're going to do is we're going to take the Y index and we're going to multiply that by the step rotation. We're going to use the negative step rotation though. So we're going to take the step rotation, we're going to multiply it by -1. We'll go into the multiply. Now if we add that in, you can see it didn't do nothing, and that's because the rotation on our control null is 0. So if I go to that second control and I go to the rotation and I take the bank to 30 degrees, you'll see now that there's 30 degrees in between each one of our instances there, the ones that are moving. So that's that part. Now what we want to do here is we only want to see them when they're between -180 and 0. So we could do that with the enable state, but I'm going to use the scaling because that doesn't change the indexes. And so we're going to do the same thing. We're going to say if the index is less than 2, which will section off the first 2 that we don't have any of this, because they're going to get handled differently. And then we're going to need a logic 2, an AS logic 2. We're going to say if that rotation is greater than -180, so that's we're going to get pi times -1. So we're just checking to see if that rotation is between -180 and 0. That's all this logic is doing. So it's checking if the rotation is between -180 and 0. And then what we're going to do is we're just going to scale that. See, now we got to put the Y index in our input here for that second logic. And then it'll work as expected. So now you can see it'll only show those instances when they're between -180 and 0. The ones that aren't, the instances that aren't equal to 0 and 1. So we're showing instances 2 through 6 when they're between -180 and 0. So that's the effect that gives us. So now the next part of this is where it gets a little bit tricky. It took me a minute to get all this. It's not that it's complex, but there's a lot of logic in this. So I'm just switching those dots just so that so for the next part of this, what we need to do here is we need to change the texture of those ones that are not moving at all. Well, first, what I'm doing before I do that is we're just going to randomize this bit. We're going to get a turbulence, and we're going to get a DP filter tools replace spot. And what we're going to do is we're going to take the alpha into the, put it on world coordinates, take the alpha into the replace spot, and we're going to use our 2D array position for the world position. So if we add that in to our rotation here, you'll see what that does. It'll offset it by this turbulence texture. It gives a little bit of randomness to it. So you'll see if we turn the opacity up for this. Turn the scale to, so you can see we can adjust the scale of the turbulence as well. I'm just testing it, just making sure that everything's working as expected. Scaling the triangles. So you can see everything's working as expected. So you can see now, you'll see 0 and 1 for all the instances that didn't move. You can see, and then the only ones that are moving are all the numbered ones. So I just wanted to make sure everything was working as expected. Just tidying these up a little bit. It does get confusing. This is going to be a tough one if you don't work along with it, because there's just so many different things going on. So what we're going to do is I'm going to get two remaps now. What we're doing here is, being that the way we did this, we have to change the texture on 0 and 1 based on, well, it's got to be based on the rotation of the other ones. So what I'm doing here is I'm just going to get two logics here, and I'm going to filter out 0 and 1. So that's what that index is going to do. I'm going to find out if the index is 0 or the index is 1. And what we're going to do is just to visualize this, because this is actually going to be done for the texture, but to visualize it, we can put it in the scale, and you can see what's happening with the scale, because it'll visually give you an idea of how this is working. So basically what we're doing here, this is to change the texture based on the rotation. What I'm doing here is I'm getting a TrueArt quantized scaler, because what we need to do is the quantization for this needs to be dependent on the that rotation here. So we're going to do 1 divided by our step angle, which was the Z rotation of our control null. The positive Z rotation of our control null. So that's what we're going to quantize by. And we're going to go into the scaler there. So now this was for number 1. This is for the instances that are 1. So if I go into the true, so if we get a math add, and what we're going to do is we're going to take the y bounds, and we're going to subtract 3 from it, because you got to remember the first two aren't don't take into account to this. So it's just the way it works out. You got to subtract 3. And then what we're going to do is we're going to multiply that by the positive step angle. And what we're going to do is we're going to add that to negative pi, basically. So we're taking the y bounds minus 3 multiplied by the positive step angle, and then we're adding that to negative pi. And then we'll go into our M maximum there. And you'll get a visual feedback of what this is actually doing in a second. And then for the min, we just want that to be at negative 180. Now it's not doing anything. It's because I forgot to plug in the remap. So if I take that remap and do the true, and if I clamp that, you'll see now it's doing what we expect. And you can look how it's quantized based on the amount of turns that it makes. So you can see when the first one comes out, it gets, and the second one comes out, and it grows a little bit more. The third one comes out, it grows a little more. The fourth one comes out, and then for the fifth one, it doesn't need to change because that one's already the same color. So that's actually working exactly how we need it to work. It took me a minute to figure out how to get this to do this. Like I said, there's a ton of easier ways to do this, but I wanted to see if it was possible to do it like this, and it definitely was. So that one takes care of that. So now what we're going to do is take care of the ones that equal 0. So for that, it's not too different. Clamp values. So we're going to take that same y bounds minus 3. And we're going to multiply that by the positive rotation. And that's going to be our maximum. And the minimum is 0 because that's fine because it's at 0. And then for the quantize, what we're going to do is just, we got to add, this is just offsetting it. Two times the negative scale there, the rotation. And then we'll go into the scale with that. So that should give us what we need. So we'll check it real quick to make sure it's working. And you can see the one when it reaches the end, the first one goes without making anything, and then as the second one goes, you'll see there's it quantizes, and then the last one it goes to the full color. So that's pretty much it. That's all there is for that. Just want to be real sure this is working how I expect it to. I believe I changed the scale of the array and stuff just to check to make sure this is working properly. I'm not sure what I do next. Oh, I just unhooked the scale because, like I said, that's for the textures. It's not for the scale, but I just had it in there so that we could visualize what's happening. So I just unhooked the scale. Okay, so what I'm doing here is I'm just setting up some controls for the nulls, for our controls. So I'm going to take the X position and use that to control the scale of our turbulence. It's just so we have control of all these parameters from the viewport. And I'm going to take the X rotation, I'm going to use that to control the opacity of our turbulence. So that'll allow us to control that turbulence texture with our control nulls. And then what I'm doing here is I'm getting the cell index and I'm going to feed that into a random scalar. And what I'm going to do is I'm going to add that into our rotation because I want to be able to have some random offset per cell basically. So you can see if I put it on 3, you can see it randomizes a whole lot. So that's with the turbulence and with the per cell randomization. So in order to control that, I'm just going to use the Y position. And what I'm going to do is I'm just going to get a mask sign. This will just change it to a negative. It'll just switch the sign. Not to be confused with the trigonometry function. So now we can control all those, our randomness per cell and our turbulence texture with that second control null. So you can see, if I take that control null and move it over on the X, that controls the scale of our turbulence, but there's no, now if I turn the rotation on the heading, that'll turn the opacity for the turbulence up. So you can see now, that's just the turbulence texture. So I'm going to turn that down a little bit to 180. So you can see that's just the turbulence texture now. And then if I move it up on the Y, that'll affect the randomness per cell. So I think I just leave that at 1 for now. So there's a little bit of randomness per cell. You can adjust this however you want. I was just trying to give myself some options when setting this up. So now what I did there was I changed the rotation, so you can see now they're only rotated by 10 degrees, so they're much closer together. And what I'm also doing is I'm changing the Y scale of our bounds. I'm just making sure everything's working here. So now we have way more instances and they're much closer together. That's all I did. So I just changed the step rotation and the Y bounds. So everything seems to be working as expected here. Now the numbering's messed up because I added more, and if you remember in the surfacing I just did a quick setup, so the numbers aren't going to be correct until I get the compound in there. If I was to go into the surface and change the mod to 20, it would work. The numbers would be correct. But so I'm just checking that the scale still works as expected, even though we changed all the rotation and the number of instances we have there, and it is still working as it's supposed to. It's just important to make sure that this is working, everything's working as expected before I move on to the next part. So that's pretty much it. That's it for that part. Now I'm going to turn this into a compound node, which is painful because there's so many inputs. Now I'm just changing the index just to see how many of these, just making sure everything's working. So you can see you can also scale them unevenly too. Like that's with the triangle scaled smaller on the X, and everything still works as it should. So now what I'm doing here is I just opened up another instance because I was having crashing issues. I could have done it in a couple tries, but I had already done it, so I knew this was just easier. I'm just going to create my compound here because I know all the inputs and outputs that I need, or how many. So for the compound outputs, I need 4 scalars, and 3 vectors. And for the inputs, yeah, it was getting crashes. I need 6 scalars and 5 vectors. I was getting crashes trying to do it in that other node network. It would let me get like 4 inputs in and then it would crash. It was just easier to do it in the new scene. And then 5 vectors. So that's all the inputs and outputs we need for that next compound. So what I'm going to do is I'm just going to export selected, call it animate compounds, and close out of that. So now just go back into our instance node editor here, and now I could just load that in. Import nodes, animate compounds. Yeah, I don't know what was up with the crashing with that. After I would get 4 or 5 inputs, it would crash. So it's kind of weird. So now what I'm doing is I'm just going to hook all these inputs up and rename them. Clip state. So it's basically just all the ones I had coming out of the other compound are the inputs for this, along with the controls for our animation. So now we'll just hook up the controls. Control position. Control forward. Control 2 position. Control 2 rotation. So that's pretty much it. So now we can cut all that stuff out of there. Paste it in here. This is kind of tedious trying to figure out where everything goes. So we got to rehook everything back up again. We got to rename our outputs. Instance scale, instance position, instance rotation. So these are just the outputs that we had going into the instancer. And then we also had the clips. We need the clip state. Y index. And this is all stuff we need for the surfacing. Cell index. Texture change. So that's pretty much it for that. And then we can hook all that back up and just make sure everything's still working as expected. We got to hook all the inputs up. This is where it gets tedious. So we need to hook all our Y indexes up. It's pretty much in all the logic. All the logic nodes use that. The 2D array position, that gets added in there. Z bounds -3. Y times the rotation. Z offset. Cell index. 2D array position. Now we can hook up our 2D array position. That's for the control 1, and then that's for control 2. So now we don't have all those controls are just outside the compound there. Y index there for the multiplier of rotation. I think that's it. We'll see. Seems to be working. Just putting it back to 7 instances with 30 degrees in between. Just making sure our scale's still working as expected. So you get basically just that quantized scale we're going to use to change the texture. That's all. That's all we're going to do. So I'm just changing the scale. Like I said, I'm just testing all this, making sure it all works. Now what I'm doing here is I'm just scaling it, making sure that part works, which it does. I also go through and test all the controller settings just to make sure the controller is doing what I expect it should be doing as far as the turbulence scale and opacity and the randomness. So that's why you'll see me messing with this for a minute. That second controller there. So like I said, I'm just testing all the because remember I have that hooked up to the turbulence texture and that random node. So now I'm just tidying this up a bit, because what we're going to do is then we're going to create a compound for for the surface editor that has all the outputs we need for that. And that's going to be a combination of all the compounds we've already made. So I'm going to go into, just so I don't have any crashing, because I know it'll work if I do it this way. I'm just going to open another instance of Lightwave, disable all the previews for the node editor. Going to get a compound, and I'm just going to add the inputs that I know I need and the outputs for our compound for our surface editor. So we need 4 scalars and 1 vector, and over the inputs we just need 1 scalar. And I'm going to export selected as animate compound or surface compounds. So there, now we have our surface compound. So what I'm going to do is now I'm just going to select everything but the instance index, put it in there, put our index, our input into the index, and then we can hook up our outputs that we need for our surfacing. So we need the 2D array position, and we need the Y index, and we need the cell index, and we need the texture change. I don't think I used the cell index in this. I do in the one I did earlier though. And we also need the Y bounds from that other node. So that's pretty much what we need for the service editor. So now I'm just going to copy that compound or cut it out of there. Go into the service editor. Delete all this stuff we don't need. So now to set this up, we need to input our instance index at 0. So right now I'm scaling the triangle down. Just so it's showing me a little more. Okay. So I'm saving everything. Setting up the camera settings a little bit here. 1 minimum, 3 max, box at fixed, photo real motion blur with 8 samples. Putting a DP dome light, 200%. Turn off the render stuff I don't need. Turn up the light samples to 8. So now we're showing that edge node, but we'll fix that right now. So what we're going to do is we're going to get a constant color. And one thing you got to be sure of is that you pick colors off for your color space settings. Make sure pick colors is set to linear. That's important. You're going to get errors using these gradients and these mixers here. So I'm just picking 2 colors here. This is what we're going to fade between. So what we're going to do is we're going to get a gradient, and we're going to use put the first key at 2 on linear, and then show output, and then the second key, put it on linear, show output. What we're going to do for the second key is we're going to get a math scalar add, and we're going to take the Y bounds here. We'll use the Y index for the input, and for the Y bounds we're going to subtract 1, minus 1, and we'll use that for key 2 position. And then we'll go into the colors with our 2 colors that we want to fade between. So you can see what that's going to do. It's just going to fade those instances from one color to the other. Now it's just dealing with the center ones now. So I'm changing it to a blue just so it gives a more distinct look, because it was kind of hard to tell with the 2 orange looking colors. But you can see how it fades in between. So now what we got to do is we got to deal with the animation for 0 and 1 basically. So we're going to get a mixer, and we're going to get a logic, and we're going to say the Y index is less than 2. So we're doing the same thing we did in that other network. We're getting instances 1 and 2, or 0 and 1, and we're separating them out. So we'll take that gradient that goes into the background color, and we'll use our logic for the opacity. So now you can see that those other 2 are just going to be white, because that's what that foreground color is set to. So now what we need to do here is we need to get another mixer, and this is where we'll deal with that texture animation. So the foreground and background color will be our colors, and then we use our texture change for the opacity, and we'll put that into the foreground. So now you can see it works as you would expect. Changes the color of 1 and 0 based on what they should be. So that's pretty much the whole effect. I did do a little bit more with the surfacing just to try and make it as close to the, well, as close to the one that he did as possible. So I'm testing all the, just to make sure everything's working. Check the colors, make sure it works. So what I'm doing is I'm increasing the instances to 20 now. So now I'm going to have many more. And you can see how long it takes them to rotate now, because we kept the same rotation in between, but we added a bunch more instances. So it takes much longer for the animation to happen. But everything's working as expected. So now I'm changing the rotation just so it doesn't take as long. So it's 10 degrees now instead of 30. And you can see it's all working as expected still. It still fades through the colors like it should, and changes the colors of 1 and 0 as they should be changed, as the other instances stack on top and disappear. So that's pretty much it for the effect. That's all there is to it. I do add a little bit of, you'll see in a second, I add a little specularity. Just because I was trying to match what his final effect was. So you'll see what I do with the edge node in a second. I'm just testing all these settings and making sure that they're working with the surfacing. And everything seems to be working good. So now I'll switch that back to a reasonable amount. Put it on 10. Put the triangle on 0.5. Fix our rotation just so they're spread out a little more. So that's pretty much it. What I think would be really cool would be doing an actual mosaic wall and texturing it like real tiles and doing that. So what I'm going to do is just for this example, I'm going to take this edge node and I'm going to get a constant scalar. I'm going to turn that into specularity, leave it at 1. And for the edge node, what I want to do is I want to put the edge width on 1 and the fuzzy edges at 0.1, and that'll just kind of make them a little bit pillowed out. And that's how Thinking Penguin did it, so that's just why I'm doing it like that. I don't know if he used real geometry or if he did it like this, but I'm just going to do it like this because it's just as good. So that's pretty much it. That is the final effect. This one was kind of painful. If you made it to this point, I'm impressed. But I hope you guys got something out of it. I mean, I think if you work through it and go through this whole thing, you'd probably learn a couple things that are pretty useful. So I'm just turning down the scale just so we can see what it looks like smaller. But that's pretty much it. Alrighty, guys, take care.